This is the fifth video in this series on species in solution, and in this video we'll be looking at the species present for a weak acid. So weak acids we know partially dissociate, and as a result of that they produce only a few ions, and that makes them weak electrolytes. And in later concept, what that also indicates is that they're very poor electrical conductors, because you need ions to conduct, and if you've only got a few ions, then you're not going to be a very good conductor. That'll come up in a video later on. So a good example of a weak acid is our classic ethanoic acid. So let's look at ethanoic acid. Here we've got our ethanoic acid with water producing ethanoate ions and hydroniums. Very few of these ethanoic acid molecules actually dissociate, and so your species present that is going to be in the highest concentration after water is the ethanoic acid. Okay, that tells us that very few of them actually do dissociate. Now the ones that do dissociate, they produce the ethanoate ions and they lose their hydrogen or proton over to water, and so the amount of ethanoate and hydroniums will be equal because of that one-to-one relationship there. What it also tells us is because you're producing hydroniums, the hydronium concentration will be much larger than your hydroxides. So listing the species present from highest to lowest: water, because of its 55.6 moles in each litre, followed by the weak acid, okay, ethanoic acid in this case. The next two species you can put in either order, but I put the ethanoate ion followed by the hydronium, but their concentrations are equal. So you could be putting the hydroniums first and then the ethanoate, that's fine. And the last species that you must still remember is present, albeit in a very small amount, is the hydroxide ions. Let's look at the graphical representation. Water present on the left hand side with that nice tall bar to represent the 55.6. Now because ethanoic acid only partially dissociates, its concentration does remain very close to its original concentration, and hence the about 0.1. Don't worry about these actual approximate values for the ethanoate and hydroniums. That's definitely not needed. All they are going to look for in your response, if you're asked to draw a graph, is the relative heights of the bars. So as long as your ethanoate ion and hydronium are of equal height, you're all good. And then those little hydroxides are going to be down much lower than the hydroniums. And because your hydronium bar is taller, this indicates it's an acidic solution. So that is a weak acid and the species present. Take home point to remember is the weak acid remains present in quite a considerable concentration. I'll catch you in the next video where I'll cover weak bases.